Hi, in this video we're going to start chapter 9 and start talking about hypothesis testing, what it is, how it works, just some of the vocabulary around it. And in this first section, we're not even going to use calculators. It's just about learning what hypothesis testing is and vocabulary. Whew, that's big because I don't have my calculator. I can make it bigger. Maybe a little too big. Okay. So let's just read through the first example and we'll kind of talk about what's going on. This is a finance journal that publishes research on current financial topics, states that the maturity term for a certificate of deposit is on average 15 years. A banker believes the average maturity term at their bank is greater than the amount quoted in the financial journal. After completing a study, the banker found that the average maturity term for certificate of deposit is 20 years on average. Okay, so we have a whole lot going on there. We are trying to identify the claim in this. We are looking for the claim, and the claim is always going to be, a lot of times, in these examples especially, you're going to see the word believes, banker believes, somebody thinks, somebody guesses. The hypothesis is what they think is going to happen, and then we will talk about, we'll test it and see if it works, if it's true. So here, the claim is a banker believes the average maturity term, anti-privacy protection. A banker believes the average maturity term, okay, let me just delete the highlighting. Try it again. At their bank is greater than the amount quoted in the finance journal. So this is what he thinks, and then they test it to be true. So you're going to see believes as a keyword, but then also greater than is another key. We're looking for greater than, less than, any words that mean these symbols, or also not equal. You'll see all the different choices that is different, is not the same, stuff like that. Ooh, okay, get rid of that one. Okay, so let's look at number 2. A recent publication states that the average percent of oxygen levels in the blood for a healthy adult is 97%. A nurse who measures oxygen saturation in patients believes the average oxygen levels are different than the published amount. Okay, I think I got a little carried away on the highlighting. We didn't really need to highlight the whole sentence. We're just looking for the claim. The claim is in that sentence. What do they believe? They believe the average levels are different than the published amount. So this doesn't have a clear greater than, less than, but it does say are different. Oops, give me my line. And different is, okay, let's just pretend I know how to work this and underline that word. Different is not equal. So same is equal, different is not equal. So that falls into this category because we're talking about inequalities. Usually when you hear inequalities, you think of these symbols, which is true, or the ones with the lines underneath it. That's absolutely true. However, not equal, which is equal with a slash through it, I'll show you in a minute, is also inequality because it's not equal. Okay, let's look at 2 more. And so it says, a business manager of a tech company states that an employee spends a daily amount of 60 minutes on the phone on average. An employee who works for the tech company believes they spend more time on the phone each day. So we have our statement. You can keep reading that, but we have our what they believe. And so spending more time each day on the phone. So our more is going to be, clever, copy, paste. Oh, yes. The more time is going to be where we get our inequality. That's greater than. So we've seen number 1 was greater than, number 2 was not equal, number 3 was greater than. Let's see what this next one is. Hopefully it's something that means less than. So it says last year, the proportion of tax filers that received a refund was 37%. Accountants believes this upcoming tax year will have a larger proportion of tax refunds than last year. Okay, well, it's also greater than. So it's this year of larger than last year. Okay. Well, it could also be less than. So these are the claims, and this is going to lead us to set up the first step of these problems. These problems have quite a few steps, and luckily we have our calculator to help us out, but it's not all calculator work, so we do need to do some writing, some picture drawing, and all that stuff in addition to the calculator. We're not even going to use the calculator today, so don't even worry about that. All right, let's jump to the other page that I posted. This is just something to have handy throughout this chapter, because this is what hypothesis testing looks like. So for starters, we're just going to talk about this right now, and then we'll come back and talk about the bottom in a minute. No, well, whatever. We'll talk about whatever. Okay, so H sub 0, that is called the null hypothesis. That is just like plain boring. Everything is equal. Yes. Alternative hypothesis, so that's H sub A. The alternative hypothesis is the claim that we are going to, what we just stated earlier, highlighted, that will be our claim. That's our alternative hypothesis. So it's going to be less than, greater than, or not equal to. And so we'll talk about the pictures in a bit, but right here, the sign in the alternative hypothesis, we're just going to look at this right now. Not equal, less than, greater than. The null is always equal. This is always equal. This one can be not equal. I think I have to write not equal because I don't think I can type not equal, less than, or greater than. Any of those three choices. If I was writing it, I would just write this little symbol, but I don't think I'm going to be able to pull that off up here. Okay, we'll come back to this. We'll definitely be talking about this more today and then throughout chapter 9. So let's go back to the first page. And we're just identifying the null and the alternative. Now, one thing to note for this, for hypothesis testing, we will always use mean and proportion. Mean or proportion. So that means we are going to talk about the population. So that means the symbol we are going to use for population mean is a mu. Yikes, I can draw better in person, I swear. And the symbol for proportion is, for population proportion, is P. Okay, so mu or P, that's what we're looking for each time. So this is a website developer wants to analyze the clicks per day on their newly updated website. Let the mean number of clicks per day be mu. So this is mean, this is mu. That's what we're talking about in this example. The website developer wants to know if the number of clicks per day is greater than 250 clicks a day on average. So again, I see average. All of this is pointing to mu. Before I start, I want to highlight the claim. The website developer wants to know if the claim is the number of clicks per day is greater than 250. We don't even need the units there. The number of clicks per day is greater than 150. So we're going to use that claim to write our null and our alternative. So we have, this is going to be a notation nightmare because I cannot type in math in this. Okay. We have H sub 0 is going, so just real quick, as a reminder, this is what I'm trying to write, H sub 0, H sub A. It's just when I write in the PDF, it does not let me be so graceful. So H sub 0 and H sub A are the two things that we're looking for, the null and the alternative. So again, the null is H sub 0, the alternative is H sub A. Both of these are going to have a mu in them. I'm going to try to borrow this mu over here. Yeah, that's not going to work. Okay. Both of these are going to have a mu in them. I'm going to draw the mu. And it says greater than 250 clicks. So the claim is the alternative. Greater than 50. Mu is greater than 50 is the claim. The null is always equal. So that's supposed to be 250. 250. So we write the alternative, and that's the claim in symbols. So the number of clicks per day is greater than 250. Mu is greater than 250. And then for the alternative, for the null, we say that same situation, but it's always equal. So we change it to equal. So we're trying to figure out, is the average number of clicks per day 250, or is it more than 250? Those are our hypotheses for this question. Oh, it's hard to say. Okay, so many words. Let's try this again. A tech company wants to study the number of production facilities that rely on modern technologies like 3D printers. Let the mean, okay, so we're using mu, number of 3D printers be mu. Okay, well, this also tells us we're using mu. If the tech company wants to know if the 3D printer is on average different than 15 3D printers per facility. Okay, so that's what we want to know. If the number of 3D printers is different than 15. I don't know why that on average is in the middle there. The number of 3D printers is different than 15. What are the null and the alternative? Okay, so the reason I'm highlighting the claim is because it helps us set up our null and our alternative, but it also is going to be used at the end, not even the end of today, like the end of these problems. We're going to be writing out the answer with these claims in them. So I like to highlight them at the beginning so that I remember what's going on. Okay, so we have mu. This thing doesn't like to let me do two things at once. Mu, there we go. And the claim is that they're different from 15. So if I can type in a not equal sign. Draw a line. It's going to be the most ridiculous not equal sign you've ever seen because the line's going to be really long. Okay, I'll just move it in. Wow, this is just taking way too long for me to move a not equal. But it worked. Okay, mu is not equal to, what is our claim? 15. And then the null is always equal, and it's always the same number. So it's going to be equal to 15. So we're using our symbols over here. Hopefully we have some proportion examples. For our claim, which is the alternative, we are going to use either not equal, less than, or greater than. For the null, we always use equal. And then over here, we're going to use the number in the claim. Two more times. Okay, here's some, hold on, my Netflix is going through. Okay, an orthodontist is interested in the proportion of patients who are, okay, proportion. So it says proportion right off the bat. We know it's a proportion problem, not a mean problem. This is very important, not only in symbols, but in terms of what steps we're going to use later this week. For the new type of braces, let the proportion of patients that are candidates for this new type of braces be P, so that's our population proportion. The orthodontist wanted to know if the proportion of patients that are candidates is less than 27%. Okay, perfect. So we have our null and our alternative. And this time, because it's a P, I can just write it all out. So our null is, or our alternative is based on the claim. So it says that candidates, so the proportion is less than And we want to write 27% as a decimal because remember, proportion is always a number between 0 and 1, just like probability. And that means our alternative is going to be equal to 0.27. So it said less than, so I put less than. 27% I wrote as a decimal. The null, I did the same thing but wrote equal. Okay, last one. The tech company wants to market its drones for home security. Let the proportion, so this is a proportion problem, be a P. The tech company wants to know if the proportion of houses that, so we want to know if the proportion of houses that have home security is different than 50%. Okay, so we have, we're going to do our not equals again. We have our null and our alternative. We know this is, well, I like to do our alternative first because that's our claim. The proportion is not equal to 50%. I'll put the not in a second. And the proportion is equal to 50%. So those are the two scenarios. Let me get my line moved over. Oh, much faster the second time. So we have proportion is, get out of your line. I used to. Proportion is equal to 50% is the null. Proportion is not equal to 50% is the alternative, and the 50% is written as a decimal. It's a number between 0 and 1. Ooh. Okay, now let's talk about the types of tests. So again, we're going to go to this last page, and we have 3 different types of tests. And here's pictures. So here's our normal distribution that we've been talking about in chapters 6 and 7. We have our normal distribution, and all 3 of these scenarios are normal distribution, and we have them cut in a certain way. So if it's left tail, if it is, here we go. If it's less than, then it is left-tailed. It's on the left side. So this is picture B is less than. This is always going to be the picture for less than because less is on the left side. Right-tailed, says right here, right-tailed test is greater than. It's on the right side, that's why it's called right-tailed, and it's greater than because all the numbers over here are greater. So this is greater than. And then last but not least, if it's not equal, that means we don't know if it's smaller or bigger, so we put it on both sides, and it's called a two-tailed test. And so not equal is two-tailed, so that is this one right here. Okay, so we are going to talk about rejecting and not rejecting, all that stuff in another video, but right now we're just talking about what type of test, and we're assigning, so the answers to all the next question are either going to be two-tailed, left-tailed, or right-tailed. Those are the 3 choices. It's multiple choice right here. And it will depend on the symbol being used, less than, greater than, or not equal to. So let's go back to page 2, and it says, what type of test should be used below? Okay, so we have a business article that states the project man, I'm just going to highlight the claims just to get into practice of that, represents an average of 40% of an IT project. An IT project manager wants to conduct a hypothesis test and claim, okay, this is easy, they literally told us the word claim, that project management represents an average of less than 40% of an IT project. Okay, so this is average, so this is mu, and well, that doesn't matter because we're not even talking about the hypothesis, but this would be mu if we were talking about writing out the hypotheses. All we're talking about is what type of test should be used. So since this is less than, this has to be a left-tailed test. Again, referring back to that picture on the separate sheet that I posted in this section. It is less than, so it is left-tailed. Less than, left-tailed. Okay. Going back here, again, I'm just highlighting the claim because it's just good practice for the rest of this chapter. An office manager claim, if they're going to give us the word claim every time, it's going to be real easy. An office manager claims that employees spend more than 6 hours on the phone per day. Okay, well, I see more than, so I know this is a right-tailed test. And also, another clue for something being mean versus proportion. Now, this is average. So average, right here, average is definitely mu. But this fact that it's a 6 and 6 is greater than what a proportion is always only allowed to be between 0 and 1. So that's another clue that this is mean. Whereas here, there's a decimal. Without even reading, I'm going to guess that it's proportion. And so it says, a journalist claims that the proportion, so it'll tell you, like, you don't have to guess. I was just saying, like, decimals will usually lead to, decimals between 0 and 1 will usually lead to proportion. Okay, so they claim that the proportion of families on welfare in a particular town is different from 0.29. Okay, the is different tells us that we are talking about not equal, and not equal is a two-tailed test. This is important. These are all important because everything that we've talked about today is a different step that you're going to put into your calculator. So none of these pieces could be skipped. We need to talk about all of them. And then on the next video, we'll start putting it together. Okay. I think my daughter is yelling down the hall. Okay, we'll just go quick and then I'll go deal with that. An advertising firm would like to carry out the hypothesis to test that the claim that the percentage of advertising is greater than, oops, I used the wrong button, is greater than 42%, greater than is to the right. A tax preparer claims that the average amount, the tax refund is greater than $650, greater than, oh, we just did greater than, so it's to the right. I get to cheat because the auto fills in my words. Not really cheat, I just mean I get to go faster than if I was writing this by hand. Okay, last but not least, a sociology professor believes, okay, we have a different word besides claims, believes teenagers spend a different amount of time on social media daily. Okay, so you'll notice that sometimes the wording is a little awkward. You know, the amount of time is different than 5.2 hours, but it's the different that we're looking for because the different tells us not equal, which leads us to two-tailed test. Now, this is it for this section. Notice the next section is 9.3, but there is homework on 9.2 and there's no worksheet or video. It's because, I don't know, maybe I even called it 9.1 A and B. I don't know, there's two sections of homework on this because one is, I just liked them both, but I didn't want to combine them because it would make too long of an assignment. So there's not a second video for the second homework assignment. It's just like this. It's just worded a little, the two sections are both worded a little differently, so I wanted to make sure you were able to see both. All right, that is, oh, I disappeared myself. There we go. All right, I'm gonna go see what's going on down the hall, and I will see you in the next video. Bye.